Key number 1, large language models are models that run on computers. All right, let's level set. Large language models are trained on massive amounts of text. They're essentially predictive models that predict the next word that comes into a text. See, you take text, you put it into this model, the model computes on it and gives you an output. The amazing thing is that these generate useful language. But it's important to keep in mind that these models, they don't have emotions, they don't know facts inherently, and they don't have goals. See, if we have an example, we say the first two words are how are blank, we're expecting the next word. We could then come up with some probability of the next word. Now, based on all of the text that it was trained on, you is the word that has the highest next probability. But there are other words that could come in afterwards. You could say, how are they? Such as, how are they doing? That also has a high probability. Now, a much lower probability is things. Maybe you would say, how are things going? That's going to be a lot less represented in the text that the model was trained on. And even a lower probability would be the word basketball. How are basketball? That's going to be much less likely, but you could envision how are basketball teams doing in the tournament. So you could come up with reasonable next words, but the model then is going to give you the word that is the most likely based on the words that you gave it in the prompt. See, this is really how the probabilistic model works, and this is really the core that underlies these large language models. All right, so a simple example. These LLMs are great at remixing different types of text and coming up with text in certain styles. So we could say, write a haiku about coffee. And we give those instructions to the LLM, and then it will return a haiku about coffee. Morning warmth in hand, steam rises with quiet joy, fuel for thoughts to bloom. Lovely, right? But this is a pretty mundane, pretty simple task for an LLM. You give it a prompt, it is going to then return a response that's the most probabilistic next set of words. Now, if we give the exact same prompt again, we say, write a haiku about coffee, it will come up with some different probabilistic set of words that will be different than the first words that it gave us. These probabilities can be tuned in your responses. We call this temperature. So when we set a temperature to 1, that's going to be a highly creative, meaning a much less likely probabilistic set of words than if you set the temperature to 0, which means that it's going to always choose the words with the next highest probability. So we can then, because this is a model, we can then tune the probabilistic nature of this model. But it's important to keep in mind that these are models at their core. All right, I said at the beginning, the key is that these are models that run on computers. So let's take a look at what this means. So you download the model, and you interact with that model by giving it a prompt and then returning text. So you might say, where is Paris? And the model will return, Paris is the capital of France. So this is a model that, again, you downloaded and is running entirely on your computer. Now, you can also interact with these models that run on other computers. So for example, Duke recently created an entire suite, the Duke AI suite, of models that you can then interact with. So if you go to this URL, you can then create an account, interact with several different models. So for example, you can act with GPT, made by OpenAI. You can interact with Llama, which is an open source model made by Meta. You can interact with several different models here. In fact, here's a whole list of the models that are currently available in summer 2025. The idea is each of these are models. These models were trained on their text, and you can interact with these models. Now, many of these models require significantly more computing power than your local desktop or laptop has. So we run this on a server, and in this case, these servers are Duke servers. So an open source model runs on Duke servers that you can interact with. So if we ask the same question, where is Paris? The model will return, Paris is the capital of France. And so in this way, we are interacting with a large language model, but in this case, it's running on Duke servers, not on your local computer. Now, the Duke AI Suite also has a portal to LLMs running on external servers. So what do I mean by that? OpenAI made several models, and you interact with it through a product called ChatGPT. Well, there are models that underlie the technology that you interact with ChatGPT. Now, this is not an open source model, which means that OpenAI is not going to give us the model, but instead what they will do is allow you to interact with ChatGPT on their servers. So Duke now has a portal to several LLMs running on external servers. So here's an example. So if you in the dropdown highlight GPT 4.1, you are interacting with a model that is called GPT 4.1 that is located on OpenAI servers. And you can ask the exact same set of questions and you expect essentially the exact same answer. Now, the interesting thing about these models is that each prompt is independent. If I say one day, where is Paris? It will come back and it will say, Paris is in France, it's the capital, right? If I come back the second day and I say, what did I ask you about the first day? The model has no intrinsic memory of our past conversations. Now, several software companies like OpenAI have created memory-like capabilities, but this is not in the model. This is some software engineering that's going to take your conversation, compress it into the essential information, and store that information in a database. So when you come back, you can say, what do you know about me? And it will then pull that information from the database. This is an important distinction from the model having memory versus building memory through software engineering practices so that you can have a more personalized experience. But LLMs aren't going to remember unless you build this memory capabilities given the software engineering. So these LLMs, they're reactive, they're not proactive, and they're certainly not autonomous. They need, right now, a prompt to then receive some response. Now, everything that I showed you so far is through the DukeGPT portal, but the same principles are true for ChatGPT. If you go to ChatGPT's interface through OpenAI and ask the same types of questions, you will then be interacting with OpenAI servers to get the same types of responses. So whether you are coming through DukeGPT's portal or going through ChatGPT's portal, you are interacting with an LLM. That LLM is a model. That model lives on a computer. And in this case, that computer is owned by OpenAI or runs OpenAI's infrastructure. All right. Now this is true beyond OpenAI. Claude is the name of an LLM model that then is running on a computer that's owned by Anthropic that then allows you to interact with that model. So this is going to be true broadly across different LLMs. Again, LLMs are models that run on computers. So how are some of these used today? Well, it's amazing. They are used as writing assistants. They are used as coding co-pilots. They're even being used as customer service bots or research helpers. But all of these right now require human oversight, where a human is going to take a prompt. The prompt then is sent to the model. The model then returns a response. And so it goes. So the key number one summary is LLMs are models that run on computers. They return text response from a user's text prompt. So you have a user, and they could be interacting with a model on your computer, a model that's interacting on Duke's computers, or a model that's interacting on a provider's computers that we oftentimes say up in the cloud. So this is key number one. LLMs are models that run on computers.